Today we want to talk about function. Function and relation. A relation, a relation, a relation is correspondence between 2 points, two sets. That is, if we have two sets, A and B, and the elements in this set, if the element exists between A and B, then we said A is corresponding to B, or Y depend on B. I will repeat myself. A relation is correspondence between two sets. Supposing we have a set A and another set B. This is set A and set B. So in set A, we have A1 as element, A2 as element, A3 as element. In B, we have B1 as element, B2 as element, and B3 as element. If the elements of these two sets to correspond to each other, then we say there is a relation. A is related to B, A1 is related to B1, the A2 is related to B, then there is a correspondence between them. While B is depending on A, while so supposing let A and B be non-empty sets, a function from A into B is relation. If A and B are non-empty sets, a function from A and B is referred to as relation that associates with each element of A, exactly one element of B. So, in other words, however, an element in B may have more than one element associated with it in A. That is a relation. That is, if A can pair with A1, B1, then A1, B2, A1, B3, they can pair with more than one element. That is a relation. But in the case of function, the element in A can only pair with only one element in B. So we talk about domain and range. A set S is the set of elements in S. Let's say this is set S and this is set Y. It's called this set of elements in S is called the domain. Domain actually means what's your input, while the codomain or range is the output you get after you input an element. So the set of elements in A is referred to as a domain, while the set of elements in B is referred to as range or codomain. The set of elements in A can have we can have the set of all the values. This is set A, set B, A, and B. So we can have the set of values A1, A2, and A3, where we have B1, B2, and B3. These are the elements in each set, while the elements in A are referred to as domain, just as I've said, while the elements in B are referred to as what? Codomain. So we have a range, set of elements of all the values, the set of all values in A, in B, that correspond to that of A is referred to as range. The set of all values corresponding to A is called the range. I repeat myself, the set of all B, the set of all B correspond to the value of A is referred to as range, while the set of all elements in A is referred to as in A is referred to as domain. So we have for example, if we have y equals to s squared, y equals to s squared. So your inputs, the value of s determine the value of y that you get. So if your s is 1, your y will be 1. If your s is 2, your y will be 4. So your y, the value, the input you input is your so your x is 0, your y is 0, your x is 1, your y is 1, your s is 2, your y is 4. Note this is called an independent, s is an independent variable. Y is a dependent variable because it depends on the value of y for values. So we can have this function f of x equals to 2x squared minus 3x. So we have to find the value of f of x plus f of 3. Firstly, f of 3, which means anywhere we see s in our function, we replace it with 3. We have 2 minus 2 into 3 squared minus 3 into 2. So we have 3 times 3, that will give us 9. 9 times 2, that will be 18. Then minus 3 times 3, this is 3, not 2. Minus 3 times 2, that will be 9. So we have 18 minus 9. So we have our f of 3 to be equals to 18. Our of 3 is equals to 18 minus 9. And that will give us that. One thing we need to take note about function is that for each x in the domain of a function f, there is one and only one image, f of s, in the relation, in the range. That is the difference between function and range. In the case of relation, s can pair with more elements in the y. But in the case of a function, there is only one and only one image of f of s in the range. Then f is a symbol that we use to denote the function. We make use of f to denote the function. Then we talk about dependent variable and independent variable. F of s, if y is equal to f of s, then s is called independent variable, or y is called dependent variable. So how to find the domain? We said you should find the domain. So the domain of a function is a value that we input into our function that gives us a defined solution. The domain of a function is the value or numbers that we put into a function that give us a defined solution. For example, when we have g of x is equal to 3x over s squared minus 4. 3x over s squared. So the domain of this function will be the value of this function that we are going to input into this function that is going to give us a particular solution. For example, if we put 1, we are going to get 3, 1 minus 4, that's minus 1. We are going to get a particular function. So a particular answer. So the domain of this set of s can be used in, we can, any number that is we're going to put in the denominator, I said the domain of this function is a number s. The domain of that function is the number s, such that s is not equals, such that s squared minus 4, that's the domain of this function g equals to 3s over s squared minus 4 will be s, such that s squared minus 4 is not equals to 0. It's not equals to 0. It's not equals to 0. If it is equals to 0, if s squared minus 4 is equals to 0, supposing you put your s to be 2 squared. So if it is equals to 0, then the function becomes an undefined. So any number that you put here, that you put in the denominator that is not equals to 0 will give us a defined answer. So therefore, s, the domain of that function is s, such that s squared minus 4 is not equals to 0. Or we said s squared is not equals to 4. Or we said s is not equals to plus or minus 2. Because if s is equals to plus or minus 2, our s squared minus 4 becomes 0, and the equation becomes undefined. Therefore, it is not a domain of that function. But any number that is not, that will not make our denominator to be equals to 0 is a domain of that function. So we can have more example. Another example of a domain is h of t equals to square root of 4 minus 3t. H of t equals to square root of 4 minus 3t. Any number, the square root of 4 minus 3t, only non-negative number have a real square root. The other number, if if you put any number in 4 minus 3, any number, if your t is equals to 1, for example, if t is equals to 1, you have a positive square root. That will be 4 minus t, that will be 1, and that will give us a positive square root. Or if your t, for example, is 6, is 2, that will be 3 times 2, which is 6. 4 minus 6, that will give us minus 2. It's going to give us a negative square root, and that would be a complex number, so which is not a domain. So you can conclude that the domain of this function 4 minus 3t must be the domain of this function must be A such that 4 minus 3t must be greater than 0. If it is greater than equals to 0, if it is greater than or equals to 0, then you can have a positive square root of real numbers. Positive square root of real numbers. So that is how to find the domain of a function. And graphs of can equally be plotted. So that brings us to the end of the class. Even questions.